Hey, good afternoon. Okay, good afternoon. So for today, our lesson will be about a nodal analysis. So I think this is something new to most of you. Yeah. Mm, Hey class, so by the way, ang test natin, yung quiz to natin na hindi natin nagawa, okay lang ba sa Friday na lang din ulit? Okay, yung quiz number 2. Okay, so yung mga test ninyo, ay may mga comment ako sa quiz 1. Oo, kaya na wala pang score yon. So halos mga tapos na ako. Ah, hmm. Kung meron kayong complaint sa paano ako nag-score, so you can message me. Wala namang problema. Okay. Sir, si Bognat daw po, di po na makakapasok today. Okay, sige. Okay, no problem, Timothy. Ayan. So, ngayong araw na to ay pag-aaralan natin ay isang method ng pag-solve ng circuit network na ang pangalan ay nodal analysis. Ayan. Record na pala ako. Sige. So sa analysis na to, ang normaling ginagawa natin ay, or nanggaling lang siya sa sa KVL, KCL, particularly KCL. Ayan. So ang basis ng analysis na ito ay KCL. Naririnig niyo pala ba ako? Okay? Naririnig niyo ako? Ayan. Sige. Okay, thank you. Ayan. So KCL yung basis ng analysis na ito. Ayan. So tinatawag natin siyang nodal analysis. So sa pangalan pa lang, so ibig sabihin, kino-consider natin dito yung node. Okay, ang analysis na to provides a general procedure for analyzing circuits using node voltages as the circuit variables. Okay, class, node voltages. So dito hahanap tayo ng mga node voltages para doon natin isosolve yung kung ano man ang kailangan nating quantity na hinahanap, voltage man yan o kaya current or even power. Ayan. So, yung mga node voltages na to, sila yung hinahanap natin. So later I will show you kung ano yung mga node voltages. And this analysis is also called node voltage method. Ayan. Okay. So, ano ba yung mga steps to determine node voltages? Okay, una, example, meron akong circuit diagram. Okay, so let's say that this is 6 ohms, 2 ohms, 3 ohms. This is 10 ampere, and let's say that this is 9 amperes. Ayan. Okay? Okay, class. So una ay, naalala nyo ba ang lesson natin about KVL? So di ba hinahanap natin sa KVL ay ilan yung nodes or junction ng circuit? Okay, so let me refresh it. Uh, so, inahanap natin dito, di ba sa KVL, KCL, inauna natin yung number of junctions or nodes. Di ba? Update. Ayan. So, nirefresh ko na. So, number of junctions or nodes. So, halimbawa dito, ilan yung junctions natin or nodes? Okay? So, ilan sila? So, we have, diba, kinoconsider natin junction or node ay pag merong nakakonect na 3 or more. 3 or more. Okay, but later we will have 2. This is a special one. Okay, 3 or more. So, halimbawa dito, ilan yung junction natin? So, 1, 2, and then 3. Ito kasi ay nag-act siya as a single junction. Pero kung meron tayong resistor dito, hindi isang junction yan. Kasi junction dito tsaka junction doon ay magkaiba sila. So, ito ay kinoconsider nating tatlong junction. So, ito, tas ito, at saka ito. Ayan. Okay. So, di ba sa KCL din natin is, ang KCL equation natin ay laging number of junctions minus 1. Okay, so halimbawa dito, tatlo yung junction natin, ang i-consider lang natin dalawa. So, ganito din sa nodal analysis. Kaya lang, yung hindi natin kino-consider, dito naman ay tinatawag natin siyang reference node. Okay, unang-unang yung hahanapin ay kailangan nyo gumawa ng isang reference node. Okay? Ano ba yung basihan para papiliin mo siyang reference node? Kung sino yung may pinakamaraming nakakonect sa kanya. So normally, siya yung 4 or madami. So dito, ilan na nakakonect sa baba? 1, 2, 3, 4. So siya yung gagamitin nating reference node. Kasi habang dumadami yung junction niya doon, kasi sini-zero out natin yung node voltage niya. Kaya siya tinatawag na reference node. Ang ina-assume natin noon na yung voltage ng node na yon ay 0. Okay? 0. Siya yung 0 voltage. Yung reference node, para siyang 0 voltage. Okay, class, kung may question kayo, tinaintindihan, mag-drop kayo ng message or magsalita kayo sa sa mic ninyo. Okay. Since ito ang gagawin nating reference node, ayan. So, ina-assume natin yan, yung voltage dyan ay 0. Okay, so ano yung natitira? Sila ngayon yung gagamitin nating kukunan natin ng voltage, node voltage. So, halimbawa dyan, tawagin natin itong VA, tapos ito, VB. VA and VB. Okay, paano mangyayari yun? Di ba kung meron kang voltmeter, pag meron kang voltmeter at yung dalawang probes ng voltmeter mo, nilagay mo dito tsaka dun sa 0, makukuha ka ng reading. At yung reading mo nun, yun yung tinatawag na VA. At yung reading mo din from reference to VB, meron kang probe, yung terminal ng voltmeter, nilagay mo dyan, yung reading na makukuha mo sa voltmeter, siya yung makukuha mo or i-assume mo na value ng VB. Okay? Una, reference node. And then mag-assign ka ng pangalan for junction. Voltage siya na. Voltage. Pero bakit voltage? Ang magiging reference natin ay KCL. Okay? KCL. Ayan. Ayan. Next step is apply KCL to each of the remaining nodes, the non-reference nodes, and use Ohm's law to express the branch currents in terms of node voltages. Solve the resulting simultaneous equations. Obtain. Ayan. Meron tayong note dyan. Current flows from a higher potential to a lower potential in a resistor. Mamaya yung supernode. Okay. So una, maglalagay tayo ng reference node. Pangalawa, mag-a-assign tayo ng voltage name para doon sa mga non-reference node. Okay. And then mag-apply tayo ng KCL. Ayan. So, kayo na mag-assume. So, halimbawa, ito wala tayong problema kasi may 9 ampere na. So, paano naman dito? So, i-assume ko yung current dito pababa. Tapos din dito pababa. Okay? Tawagin ko yung, let's say, I1. Ito, I2. Ngayon ko lang gagawin yan. And then, meron pa ba? Ito may current na. So, ito na lang sa taas. So, ito naman ay I3. Ayan. Ngayon, mag-KCL tayo daw. Sabi niya, mag-KCL daw tayo doon sa mga non-reference node. So, ito, tsaka to. So, KCL at VB. Okay? VA. Kung mag-KCL tayo at VA, so magiging KCL natin yan is ito, 9 is papasok, minus I1 minus I3 is equal to 0. Ayan. Okay? Okay, next. Kaya lang nasabi dyan, sa B, instruction, use Ohm's law to express the branch currents in terms of node voltages. Okay, class, kung alam kong voltage dito, kinuha ko yung voltage dito, paano ko makukuha yung I1? Di ba Ohm's law? So that will be equal to 2, di ba V is equal to IR? So that means I is equal to V over R. Tama ba? So therefore, I can write this as 9 minus I1 is VA over 2 minus I3, kay I3. Kaya lang class yung I3, pupunta siya dito. Eh di ba pag ang dito ang direction ng current, that means ang positive ng resistor ito, tapos ito to. Kaya nakasulat dyan, di ba? Current flows from higher potential to lower potential. So ibig sabihin, sino yung mas mataas sa dalawa? Siyempre, mas mataas yung VA. So magiging kang VA minus VB over 6. Yun yung I3. Yung voltage nito divided by yung resistance. Kaya meron kang I. Eh higher yung A kasi nandun yung positive. Ang reference natin VA, ha? Siyempre, ano yung positive? Di ba? Negative. Okay, so that's equal to 0. Ayan. So ito na yung ating first equation. So gagawin lang natin yan ay simplify lang natin. So dapat mawala yung denominator. So magiging niya mamaya na lang natin gawin. Okay, may question ba kayo sa KCL at VA? Wala. Okay, let's continue. Now, KCL at VB. Yeah. Okay, kung mag-KCL tayo dito, so ibig sabihin, yan ay I3 plus 10 minus I2 is equal to 0. Ulitin lang natin ang ginawa natin. So I3 same. Okay, I3 is papasok. So that will be VA minus VB over 6 plus 10 minus I2. I2 naman, pababa din yan. So ibig sabihin ng positive, negative. So magiging VB over 3 is equal to 0. So this will be our second equation. Ilan na unknown? Diba dalawa lang? Pwede natin siyang isolve. Okay, kung isosolve natin yan, so yung unang equation ay multiply natin ng 6 para ma-simplify. So magiging 54 minus 3VA minus VA plus VB is equal to 0. So ito niyan ay negative 4VA plus VB is equal to negative 54. Ito na yung ating first equation. Okay? Next equation ay ito. Multiply natin din ng 6. So magiging VA minus VB plus 60 minus 2VB is equal to 0. So, magiging VA minus 3VB, VB is equal to negative 60. So this is our second equation. Solve na natin simultaneously. Okay. May question? Algebra na lang kayo. Wala. Wala question. Yeah, we are actually getting away from KVL, KCL, which is the longest method of all. Now we're going to the shorter versions. And nagsisimula na tayo sa pinakauna, yung nodal analysis. You don't need to do a lot of equations. Ayan. Sige. I don't know if I'll continue this one. Okay, so let's have an example. Okay, example number 1. Actually, it's of the same figure. Number 1. Yeah, it's of the same figure. Let me remove this now. Para lang makita kong malaki yung papel ko. Ayan. So our first example, I will explain supernode later. Yeah. So we have an example here. So given ayan. Okay, sabi dyan is find V1 and V2. So these are the node voltages V1 and V2. Okay? So find V1 and V2. Okay, first method is we need to find the reference. It's obvious because we are given this V1 and V2. So that means we will assume that this is our reference. Yeah, wherein the voltage of that is 0. Okay. Next, you assume direction of current. Okay, so let me assume that the current here is downward. And then the current here is to the right. And then current here is downward. Ayan. Okay? Okay lang naman na maglagay kayo ng... sige. For now, siguro lalagyan ko. This is I1, I2, and I3. But for later, it's okay na hindi na kayo maglagay ng ganon. Kung sanay naman kayo, no? Okay. And then let's start. So KCL at V1. Okay. So that's equal to... So 1 ampere is moving towards V1. So that's positive. I1 is downward. So minus I1. And I1 is moving away from V1. So that's minus I2. It's equal to 0. Okay, so let's apply transform the current into node voltages. So the minus. So I1 is nandito siya. So that's kasi 0 naman yon. Kaya di ba lower potential siya. Kaya V1 minus 0 is still V1. Kaya di na natin nun lalagay yung 0. Kaya magiging na lang siyang V1 over 2. Minus, so higher potential is V1. So V2 doon. Kasi kung baliktad naman siya, magiging V2 minus V1. Okay, so this time is V1. But for this example, it's V1 minus V2 over 6. Yeah, is equal to 0. Yeah. So, and then let's simplify. So, let's multiply 6 para mawala yung denominator na to, yung LCD nila. So, 6 times 1, that's a 6 minus 3v1 minus quantity. v1 minus v2 is equal to 0. And then we simplify. So, this is negative v1 plus v2. So, that will be negative 4v1 plus v2 is equal to negative 6. So, this is our first equation. Okay, let's have KCL at V2. So that will be KCL at V2. So that's I2 minus I3 minus 4 is equal to 0. I2, ito yon. So lower potential is V2. So that will be V1 minus V2 over 6. And then I3, bababa, minus, negative yon, minus V2 over 7 ba yun? Okay, V2 over 7. Hindi ako naluto sa sulat. And then that's equal to, ito na suppose na natin, 4. Okay, so let's get the LCD para ma-eliminate yung denominator. So let's multiply it by 42. So we'll have 7 V1 minus 7 V2 minus 6 V2 is equal to hindi ako marunong mag-ano. Sa calculator. Ayun. It's 42 times 4, 168. Yeah. So this will be 7v1 minus 13v2 is equal to 168. So this is our second equation. Okay. Okay, so let's solve now simultaneously. I'll have negative 4v1 plus v2 is equal to negative 6 and negative 7v1 minus 13v2 is equal to 168. Ayan. So let's do elimination method. Wala na akong tinta. So let's just eliminate v2. So let's multiply the first one by 13. So that will be negative 52 v1 plus 13 v2 is equal to negative 78. Okay, so let's copy. Negative 7 v1 minus 13 v2 is equal to 168. We add. Cancel. So that's a negative 59 v1 is equal to 168 minus 78. 90. Then divide this by negative 59. So v1 is equal to tama ba ako? Ano? So this should be positive. Okay, so this is not. Oh, this is just 45. Okay, negative 45. Negative 45. So that's equal to negative 2. Okay, negative 2 volts. Okay, so therefore, at equation 1, negative 4 V1 plus V2 is equal to negative 6. Negative 4 times negative 2 plus V2 is equal to negative 6. So V2 is equal to this is positive 8 transpose negative 14 V2. 14 volts. 14 volts. So the answers are negative 2 volts and negative 14 volts. Okay? Ngayon. Any question? Okay, sige. Let's proceed to the next example, I think. Okay lang negative, yeah. Yes. Mm-mm. We're expecting naman kasi, tignan yung source natin. Ang source kasi natin ay 4 and it's in this direction. So we're assuming na ibig sabihin mas mataas yung potential ng reference compared dun sa V1 and V2. Okay? Mas mataas yung reference ito. Kasi parang yung current natin is papunta dito. Halimbawa itong 4 na to, so it will split into 3. Diba? So nandito sa baba yung mga positive. Kaya nakatutok sa taas yung negative. That's why it's okay, Andre. Okay lang naman. Okay, let's have another example. Okay, number 2. Okay. So, using this, we are given this example. Medyo pangit yung drawing ko. Okay. So, what is the power absorbed by the 4 ohm resistor? Okay. So, what is the power absorbed by the 4 ohm resistor? Okay. Since we have the resistance already, we can either get another quantity like the voltage or current. So, it depends. Okay, it depends on sa masasolve natin. Okay, pero syempre, lesson natin ay about nodal analysis. Ayan. So, it is not determined in this example, which should be the reference node. So, ilan yung junction natin dyan or ilan ang node natin? So, ang node natin dyan ay, so meron tayo sa baba, 1, 2, 3, 1, 2, 3. So, ito yung isa. And then, meron din tayo dito, 1, 2, 3, 4. Meron din dito. Then, meron din dito, 1, 2, 3. Ayan. Okay, ang question ay, kayong pipili. Ano ang gagamitin nating reference? Okay, ang sabi ni Noel ay we will be using this as our reference. It's okay. Walang problema. But we can also use this one or we can use this one. Okay? So, wala nang problema. Isa ito kasi ay apat yung nakakonect. So, tama. So, apat yung kakonect. Imagine niyo kung apat yan. So, yung KCL natin, apat yung current. Tama ba? Apat yung involved na current. So, kung ito, reference natin, ito kasi tatlo lang, ito tatlo lang din. Okay? So, let's have that as reference, wherein at the reference, the voltage is equal to 0. Okay, next. So, let's assume current per branch. So, current dito is okay. Meron na tayong current din dito. How about yung current dito? Yeah. Okay, so probably this will be, kahit ano laman. Pababa. Tapos dito ay pakanan. Tapos dito ay pababa. Ayan. So, let's call this V1 and then this one is V2. Should I put some names? Sige na nga. I1, I2, I3. Ayan. Okay. Now let's continue. Let's have the KCL at V1. Ay, nako. Wala ng tinta. Ayan, V1. So we'll have 5 minus I1 minus I2 is equal to 0. So 5 minus I1 is, pagbaba siyang ganyan, so positive ito, higher to, lower ito. So that will be V1 over 4. Okay, V1. Kasi reference natin yun. V1 minus 0 over 4. Next, minus I2. Okay, papunta yung I2 dito sa V2. So higher niya ay V1. Kasi remember, current flows from higher to lower. So that will be V1 minus V2 over 2. Okay, that's equal to 0. Then let's multiply this by 4. So we'll have 20 minus V1 minus 2V1 plus 2V2 is equal to 0. I distribute na agad yung negative. Okay? Yung negative. So, dinistribute ko na agad yung negative. Yan. Yung negative sign. Then we'll simplify. So, that's negative 3V1 plus 2V2 is equal to negative 20. So, this is our first equation. Ayan. Okay, next. KCL at V2. KCL at V2. So, that will be... KCL, V2. So, papunta dito, I2 plus I3 minus ten. Tama? Is equal to 0. Okay, so I2 is V1 minus V2 over 2 plus I3 I3 ay pabaliktad. So, ang higher niya ay ito. So, magiging siyang 0 minus V2 over 6. That's our reference. Okay? Okay, minus 10 is equal to 0. So, let's multiply this by 6. So, we'll have 3V1 minus 3V2 minus V2 minus 60 is equal to 0. So we'll have V3V1 minus 4V2 is equal to 60. Okay, this will be our second equation. Right. So, simultaneous equation na lang natin. So, this is equation 1, that's equation 2. Let's just have, let's negative 3V1 plus 2V2 is equal to negative 20. We just add. Cancel. Tama ba? Ayan. So this will be negative 2V2 is equal to 40. And then divide this by 2. So negative 2. V2 is equal to negative 20 volts. Ayan. If V2 is negative 20 volts, therefore, saan natin siya substitute? Dito na lang. Ayan. So, therefore, at equation 1, negative 3V1 plus 2 times negative 20 is equal to negative 20. So, V1, negative 3V1 is equal to 20. Tama ba? No, negative 40, positive 40. And divide this by negative 3. So, V1 is equal to negative 20 over 3 volts. Okay, any question? Yes. Ay, akala ko nagka-type ka, Noel. But I was waiting for your question or your message. Si Clarence pala. Okay. Si Cyril. We're not done yet. We're still. Okay. Okay, Cyril. Okay. Thank you. So we're not done yet. We're still, okay, we just found V1 and V2, the node voltages, but we are looking for power P. Okay, P, that is the power absorbed by the 4 ohm resistor. Ayan. So knowing V1 and V2, how can we get the power? Okay, so, okay class, ang formula natin power is either pwede tayo sa voltage o kaya sa current since may resistor na tayo. And since meron naman tayong voltage, then ano ang voltage? Ayan, across 4 ohms. Okay? So, gagamitin na, dito ko na susulat ha, sayang kasi yung paper. So, therefore, power is equal to, since voltage naman yan, kukunin na natin siya sa voltage. Ayan. Ang kailangan lang natin, ano ang voltage ng 4 ohm? Okay? So, ang 4 ohm pinag-uusapan, and the direction of current is in this direction. So, that will be V1 minus, because that's the reference, it's 0. Ayan. Okay? V1 minus 0. So, therefore, power is equal to, what's V1? That's the V1. So, negative 20 over 3 minus 0 squared all over 4. So, power is equal to 20 divided by 3 squared divided by 4. It's 100 over 9 watts. Ayan. So, the answer is 100 over 9 watts. Probably I will yun. Sir, bakit po yung sa 6 ohms negative yung V2 kahit papunta sa kanya yung current? Pero sa 4 ohms po, negative po V1 kahit palayo po yung current. That's a good question. Meron kasi tayong note. If you will recall, if you can recall, that's a good point. If you can recall the equation. Ayan. So, meron tayong note dito. Yeah. So, this note. Current flows from higher potential to a lower potential in a resistor. Okay, so current flows from a higher potential to a lower potential. Okay, so mabalik ako doon sa circuit natin. Diba, kinuha natin is I3. Kung kukunin natin yung current na I3, asa ng higher potential? Diba, current flows from higher to lower. So, ang potential, higher potential natin ito kasi nanggagaling yung current dito at ito yung lower potential. Higher, lower. Pag nagbabago yung mga reference natin, nagbabago din yung nodal voltage. Kung ito ang pinili nating reference, magbabago itong dalawa. Kasi ang dalawang to nun, nakabase sila dito. Kung ito ang pinili nating reference, yan yung mga nakuha natin. Pero pag ito din ang pinili nating reference, magbabago na naman yung dalawa. Hindi sila nakafix. Kasi depende sa pagpili mo ng reference junction or reference node. And since, di ba, kahit positive ito dahil papunta siyang ganyan. Ang kinukuha natin kasi, yung value ng current. Okay, ang value ng current. Ang value ng current natin kasi ay, susunod natin is higher potential minus lower potential over the resistance. Since pababa ito, susundan natin yung note natin na current flows from higher to lower. Kaya pipili na 0 minus, kasi inassume nating reference to, ito ay 0, 0 minus V2. Kaya siya naging 0 minus V2. Okay. Okay, no problem. Yeah. Kung iba yung pinili nating reference, magbabago na naman yung value nila. They'll not be the same. Okay, so wanna try that one? Sige nga. So we can try that one. So, what if we change the reference? Same drawing, same problem, but we will change the reference. Yeah. Hindi yung pipiliin nating reference. Ang pipiliin nating reference yung sa baba. Or ayan. So we will follow the same direction of current para makita nyo lang yung difference. I3, I1, I2. Okay, so this one is V1. Okay, so ito na ang tatawagin nating V2 and this will be our reference. Okay, so that will be our reference wherein that the voltage is 0. So, ididiretso ko na lang, i-shortcut ko na lang. Okay, KCL at V1. Okay, so I'll have 5 minus, okay, I1 is V1 minus V2 over 4. And then that is minus V1 over 2. It's equal to 0. Ayan, kasi it's V1 minus 0. This one is V1 minus 0. So this is like V1 minus 0. Okay, so multiply this by 4. So we'll have 20 minus V1 plus V2 minus 2V1 is 0. Negative 3V1 plus V2 is equal to negative 20. So this is our first equation. Okay, KCL at V2. So, medyo apat lang ito. So, una is negative 5. Okay, plus 10. Okay, so this one is papunta sa kanya plus. Kaya lang it should be V1 minus V2. Higher potential, lower potential. V1 minus V2 over 4. And then this one is higher minus V2 over 6. That's equal to 0. So let's multiply this by 12. 5 times 12, 60. Okay. Plus 3, so 3V1 minus 3V2 minus 2V2 is equal to 0. So we'll have 3V1 minus 5V2 is equal to negative 60. So this is our second equation. So we just add them. Then add, cancel. So we'll have 4. Negative 4V2 is equal to negative 80. So V2 is equal to 20 volts. Okay. Next. At equation 1, asan ba? Ito, negative 3v1 plus 20 is equal to negative 20. So negative 3v1 is equal to negative 40. So v1 is 40 over 3 volts. Ayan. Okay, so therefore, to get power, so that's still V squared over R. Ngayon, ano ba yung V? So, in-assume natin na ganyan direction. So, that is, yung V natin is V1 minus V2. So, that's equal to V1 is 40 over 3 minus 20. So, that's equal to negative V is negative 20 over 3 volts. So, power is equal to negative 20 over 3 squared over 4. And that's still 100 over 9 watts. Ayan. Okay. Did you see the difference? So, nagbago na yung value ng V1 at saka V2. Nakadepende kasi siya sa reference. Okay, class. So, base dito, sino pinakamataas sa voltage? Di ba still V2? Okay? V2 pa rin ang pinakamataas. Kaya, nung ginawa natin siyang reference, nag-negative yung dalawa. Kasi, mas mataas talaga yung voltage ng V2. Kaya nag-negative yung dalawa. And since hindi na siya yung ating reference, itong ginawa nating reference, nag-positive yung V2 kasi mas mataas talaga siya sa dalawa. So positive talaga yung V2 at nag-positive yung V1. Kasi yung reference natin ay mas mababa sa kanilang dalawa. Eh, ang napili nating reference kanina, yung pinakamataas, talagang magne-negative yung dalawa. Okay. Yung question kanina, we always need a reference. It's part of the method. It's part of the solution. You need to select a reference node. Okay? Okay, class. Mas madali ito kung meron kang voltage source. So, halimbawa, ito ay hindi siya current source, voltage source siya. Okay? Kung voltage source ito. Kung voltage source ito at reference mo to, V2 to, automatic, kung ano ang value nito, siya din ang value ng V2. Kasi voltage naman siya eh. Okay, so let's have an example similar to that one.
Screaming on it, I was dead.
Okay, so we're given this circuit. So we want to find the value of ano yan? The power supplied by the dependent source. So what is the power supplied by the dependent source? Okay, so in this example, we are to find the power. Ito. Okay, so we ran out of time. Okay, so probably okay, so I'll just give you an assignment. So we'll just continue this on class. On Wednesday, I won't be around. I won't be around on Wednesday kasi may interview ako. Dahil may activities sa school. Meron kaming interview ng 3 o'clock. So, siguro, hindi. Maaga kami pinapapunta dun eh. Kung saan nang pwede, kahit 30 minutes magklase tayo. Pero, it might not be possible. May interview kasi kami ng 3 to 4 para sa school. So, hindi ako po pwede. Mag-asynchronous muna tayo ng Wednesday. And then on Friday, I'll give you your test which will be submitted on Saturday. Yan. Kagaya ng dati, yung quiz 1 natin. So quiz 2 will be on Friday. You'll submit it on Saturday. Okay, and later, we will have a double experiment. But of course, I will just extend the submission. Yeah, I'll explain 2 experiments later and then you'll just do. Kailan, Rainwell? Sa Wednesday? Meron. Hanggang 4 lang yung interview namin. 3 to 4 only. So, inisip ko nga kung hahabol pa ako sa 202 pero para pantay na lang, hindi na lang. Pero pag meron mag-meet ng laboratory sa Wednesday. Okay. Hey, do you have any additional question? Ayan. Kung wala, so good day class. See you later. Okay, see you sa laboratory natin later. Okay.